Hey, welcome to the second lesson of measurement unit part 2. In this unit, in this lesson, what we want to do is we want to convert between Imperial and SI. So in the last lesson, we went back and forth between different Imperial measurements. Now what we want to do is we want to go between the two systems. So if we look at our formula sheet, we're going to be using these two boxes here. And again, remember, these are approximate conversions. They're not exact, but they give us really close answers to, like, exact answers. We don't need this to the millionth decimal place, right? If we're going to go to Home Depot and we have a metric measurement and we need to turn it into Imperial because that's how Home Depot sells lumber, then we don't need to know down to the millionth of a decimal place how long this piece of wood is going to be, right? So we're gonna use these approximate ones, and remember that in our course we want to have all of our answers correctly rounded to at least 2 decimal places. If we have more decimal places, that's fine, unless we're talking about money, but we want to have at least 2 decimal places rounded correctly in our answer. So hold on to the sheet because we're going to kind of go back and forth, but let's start with the first example here. A bowling lane is approximately 19 meters long. What is this measurement to the nearest foot? So meters is an SI unit and feet is our imperial unit. So we have to go back and forth between the two, right? That's what this lesson is going in between those 2 different systems. So we want to change meters to feet, and I really want you to learn unit analysis. If you're comfortable just multiplying or dividing by the conversion factors that we have on our formula sheet, that's great. This is not particularly tricky, but I really want you to take the time to learn unit analysis, because when you're in physics class next year or you're in chemistry class next year, unit analysis is going to get you to any kind of unit that you want. It's kind of fun actually, you get to cancel stuff out. So we want to use unit analysis, and the way we set it up is we have our starting number and we're going to multiply by a conversion factor, and we're always going to multiply. We're always going to set it up as multiplication, and then when we set it up, we'll see, do we put multiplication or do we put division into our calculator? The way we set up our conversion factor is to have it so that the unit that we want to cancel is going to be in the denominator of our conversion factor. And I'll show you what that means with this first example. We're going to start with 19 meters. Let's go to our formula sheet here. And here we see that 1 meter is approximately, we need meters and feet, don't we? So we need to find where we have meters and yard here, and in this box here, we have feet and meters. Okay, so 1 foot is approximately 0.3048 meters. So that's the conversion factor that we're going to use. So what we want to do is we want to set it up so that it's here. I'm going to try to, how can I have this so that it works? So you can see both. Let's do it like this. Can we see? There, you can see that conversion factor right there at the top, and here's my work here. So 19 meters is what we started with, and let's multiply it by our conversion factor. And let's set it up so that meters is in our denominator and feet is in our numerator. Okay, and then we just take the numbers from our conversion factor. So 1 foot is equal to 0.3048. Squish that number in there. So really what we're doing is we're taking 19 meters and we're multiplying. This is just 1, right? We're not making 19 meters bigger or smaller. We're just changing its form. Because these things are equal, right? They actually, as a fraction, equal 1. But what's really awesome here is our meters cancel, because we have meters over meters. So our meters cancel and we're left with feet, and that's exactly what we want. And what we have left tells us what to do in our calculator. So we would do 19 times 1. We don't have to do 19 times 1. We can just do 19 divided by 0.3048. So we can see that this is division. So 19 divided by 0.3048 gives us 62.33595,801 feet. Okay, because that's what's left. Our meters cancel out. Well, we don't need that many decimal places, and the question is actually telling us to round our answer to the nearest foot. So the closest, this is actually closest to 62 feet. And what we want to do is we want to make sure that answer makes sense. We know that a meter is, well, it's about the distance between, if you stretched out your arm, it would be about the distance between, you know, your nose and the tip of your finger. It's about how high the doorknob is from the floor up the door to the doorknob is about a meter, right? Thinking about a meter stick in class, would a meter, right? And then thinking about how big a foot is, right? Literally, it's your foot or the length of a piece of paper. Would 19 meters have 62 feet? Is that a reasonable number? And it is a reasonable number. We want a meter is much longer than a foot. So if we're going to change 19 meters into feet, 62 feet is a reasonable answer. If I would have taken 19 and multiplied it by 0.3048, it would have got 5.79. And 19 meters is not equal to 5.79 feet, right? So we want to make sure that we're thinking about the reasonableness of our answer, especially if we're getting used to this new thing that is unit analysis. Okay, I hope that makes sense. Go back, watch the video again if you need to. Google unit analysis and look for some videos to help you with it, and you'll see that it pops up all over the place in a bunch of math and science calculations. All right, here's another one. After meeting in Emerson, Manitoba, Hannah drove 62 miles south and Farron drove 98 kilometers north. Right, Emerson's right at the border, so Hannah drove 62 miles into the US where they use the imperial system. Farron drove 98 kilometers north into Canada where we use the metric system. Who drove further? So we have a choice here. We could either change Hannah's miles into kilometers, or we can change Farron's kilometers into miles. Okay, so we have that choice. So let's take Hannah's miles. Let's take 62 miles and let's change it into kilometers. So what we need to do is go to our formula sheet and find a conversion factor that has kilometers and miles. We actually have two of them. Okay, so you can use either of these. It really doesn't matter. As long as you're using unit analysis, it'll show you if you're going to multiply or divide by these numbers that you get for the conversion between them. So I'm going to actually, just so we're doing a slightly different calculation, I'm going to do 62 miles and I'm going to multiply. I'm going to actually use this conversion factor here where 1 mile equals 1.6093 kilometers. So I'm going to set it up so that I have miles down here and kilometers up there, right? So we can see our miles are going to cancel. And then we just take the numbers from our conversion. 1 mile, and 1.6093 kilometers, 1.6093 kilometers. Okay, and now we can see that our miles cancel out. Miles divided by miles is 1, so there's no unit there anymore. They cancel out, and we're left with kilometers. And we can also see that our our setup here is telling us what operation we want to use. So we would do 62 times 1.6093 divided by 1. We don't need to divide by 1. Anything divided by 1 is itself. So let's take 62 and multiply it 1.6093, and we get 99.7766, and we're left with kilometers. Okay, we get kilometers. So Hannah drove 62 miles, which is equal to 99.7766 kilometers, which is further than Farron, because Farron only drove 98. So Hannah drove further. Whoops, further. Now, we could have done this where we used a different conversion factor, right? Where we used 1 kilometer divided by 0.6241 miles. And we would have done that. In that case, we would have gone 62 times 1 divided by 0.6214. Well, actually, let's put that in our calculator. 62.4 is 99.7747, which is a slightly different answer than we got here. If we, go down to 4 decimal places or even 3 decimal places. That's okay. Again, because these are approximate conversions, we're going to get approximate answers. Okay, so if you get a slightly different answer than what's in the answer key for your independent practice, that's okay. I really just want you to look at the ballpark. 99.7766 is really pretty close to 99.7747, right? Those are pretty much the same number. So we're in the same ballpark here. We could have also actually taken Farron's 98 kilometers and turned it into miles, right? By starting with 98 kilometers and then multiplying by a conversion factor that has kilometers in the bottom, right? We could have actually gone 1.6093 kilometers is 1 mile, right? And here we would have done 98 times 1, which is just 98, divided by 1.6093. So that's where some students kind of get confused, just because there's so many ways to solve a problem like this. But that's actually, what's really great about it is we've got a lot of tools in our toolbox, and if we just kind of understand how to cancel units and get back to the unit that we want, we've got a really powerful tool for conversions. All right, let's take a look at the very last problem on this page. Alex is 6 feet 2 inches tall, and he needs to put that height in centimeters on his driver's license. So let's turn 6 feet 2 inches. Let's turn that into just inches first, right? 6 feet is 6 times 12 plus 2 is 74 inches. So that's a lot easier to work with if we just have our imperial measure all kind of in one form here. So Alex is 74 inches tall. We want to change that to centimeters. So let's find an inches to centimeters conversion. We've got one here and we've got one here. I'm going to use this 2.54 because it's a common one. You might actually even know that already. So let's take 74 inches and we're going to multiply it in a way in our conversion factor that has inches in the bottom, centimeters in the top. 1 inch is 2.54 centimeters. So our inches cancel and we're left with centimeters. And we can see that we need to multiply these two numbers together. 74 times 2.54 is 187.96, and we're left with centimeters. And that's centimeters. So Alex is 187.96 centimeters tall. A lot of students don't want to use unit analysis for this lesson. They want to just multiply and divide in a way that makes sense to them. And that will get you the right answer, but I really want you to learn this new strategy of unit analysis, especially if you're taking chemistry and physics classes next year.